16.
How do you know that, Tanner?
Because y equals 16x.
Y equals 16x. 1/2 times 16 is 8. 1 times 16 is good. 3/2 times 16 is 24. 2 times 16 is 32. Very good. Very nice. Okay. Remember last week, well, a couple weeks ago when we were doing slope? You've done the picture. You've done the graph. Could you have looked at the graph and found that it was rising 16 every time? Even though, and now see, that's where you gotta, don't let it trick you. Remember how we numbered it? Remember how we numbered it? We're numbering, yeah, at 0, 0, and then now, whoa. It goes 8 for every half. Okay. But if we're going, yeah, that is true. I don't like that very well. I would run it as 16, be the easiest way as well. But you got to be careful and make sure you know how it's numbered. Okay? So my slope or my constant proportionality is 16. Good. Any questions on this one? How we can take the data, make the graph, answer the question. Takes a little bit of time, but is it doable? Okay? Now, going back to the story here, we're talking about the vacuum cleaner, right? Talking about a vacuum cleaner. What if the battery weakens and the robot begins cleaning less and less area each minute? At that point, would X and Y show direct variation?
No, because what are is going to be, there's different types of vacuum cleaners. This one is spinning wheel, the one that's spinning around, it would start slowing down and then it would be picking up less and it doesn't have enough force to do the big stuff.
Okay. Gabriel says no. Okay. How many of you agree with the no? You agree that, yeah, there's no way they're going to be at a direct variation. Okay. Julian, what do you think? What happens is that battery weakens. Alice? Okay. Does it weaken at the same rate?
No, it's going less and less and less.
Yeah. That rate of change is no longer constant. Did you have anything you wanted to add to that? Nope. Tanner?
Slope would change.
The slope would definitely change. Okay. But the fact that it's not going to have a direct variation, is it going to maintain a linear graph, do you think? No, it won't. Okay. All right, let's go on. On a separate sheet of paper, complete the following and turn it into the drawer before you start your assignment. You are to get out a separate sheet of paper, put your name on it. Answer this question. Tell whether X and Y on this, which is in your notes as well, tell whether it is showing direct variation, and you have to be able to explain it. Pardon? No, you could if you want to. If that's the way you choose to do it so that you can answer the question, that's fine. You don't have to graph it, but you could. Okay? And then the last page of your, you don't have, now this page is on your notes.
Yeah.
Okay? This page is not. So you'll need to write that down for yourself. Because this is the assignment. But this other is done before you do that, because I'm going to look at them real quick and I'm going to give you points for it. I want to check your level of understanding before you start spending a whole bunch of time. And I have the assignment written on the board as well, cause I wanna stop the